तू शाहीन है परवाज़ है काम तेरा। तू शाहीन है परवाज़ है काम तेरा। तेरे आगे आसमां और भी हैं। Assalamualaikum and a very good morning to everyone present here. On behalf of the Department of Chemical Engineering, Aligarh Muslim University, we, Fatima Waji and Fatima Khan, take immense pleasure in welcoming you all to this much anticipated university extension lecture on the topic Science and Scientists in the New Millennium, a Brave New World.
We extend our heartfelt greetings to our esteemed chief guest, Padma Shri Professor Ashutosh Sharma sir, and all the distinguished professors and dignitaries present here, both on and off the dais. We also warmly welcome all our respected faculty members and students. Your presence here truly enriches this academic occasion. To commence this gathering on a spiritual note, as is the cherished tradition of our beloved Aligarh Muslim University, we begin with a recitation of the Holy Quran. I warmly invite Qari Ajmal Sahab to enlighten us with the sacred verses.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم إن في خلق السماوات والأرض واختلاف الليل والنهار لآيات لأولي الألباب الذين يذكرون الله قياما وقعودا وعلى جنوبهم ويتفكرون في خلق السماوات والأرض ربنا ما خلقت هذا باطلا سبحانك فقنا عذاب النار ربنا إنك من تدخل النار فقد أخزيته وما للظالمين من أنصار ربنا إننا سمعنا مناديا ينادي للإيمان أن آمنوا بربكم فآمنا ربنا فاغفر لنا ذنوبنا وكفر عنا سيئاتنا وتوفنا مع الأبرار ربنا وآتنا ما وعدتنا على رسلك ولا تخزنا يوم القيامة إنك لا تخلف الميعاد صدق الله العظيم.
In the name of Allah, the most beneficent, the most merciful. Verily, in the creation of the heavens and the earth, and in the alternation of night and day, there are indeed signs for men of understanding. Those who remember Allah, standing, sitting, and lying down on their sides, and think deeply about the creation of the heavens and the earth, saying, Our Lord, you have not created all this without purpose. Glory to you. Give us salvation from the torment of the fire. Our Lord, verily, whom you admit to the fire, indeed, you have disgraced him, and never will the wrongdoers find any helpers. Our Lord, verily, we have heard the call of one, Muhammad, calling to faith. Believe in your Lord, and we have believed. Our Lord, forgive our sins, and expiate from us our evil deeds, and make us die in the state of righteousness, along with the pious believers. Our Lord, grant us what you promised to us through your messengers, and disgrace us not on the day of resurrection, for you never break your promise.
Thank you, Qari Sahab, for your wonderful recitation. We are gathered here today to witness an intellectual discourse that aims to shed light on the evolving role of science and scientists in shaping our world, a world that is increasingly complex, fast paced, and deeply intertwined with technological advancement. We are truly privileged to be in the company of Padma Shri Professor Ashutosh Sharma Sir, a stalwart in the scientific community and a beacon of academic excellence. His illustrious career and visionary leadership in Indian science and technology need no introduction. We look forward to the insights he will be sharing with us today.
I also take this opportunity to extend a heartfelt welcome to Professor Nasar Ahmed, Dean of the Faculty of Engineering and Technology, Professor Mohammad Muzammil, Principal of the Zakir Hussain College of Engineering and Technology, Professor Mohammad Danish, Chairman of the Chemical Engineering Department of the Zakir Hussain College of Engineering and Technology, Professor Ahmed Tariq Jamil, the Organizing Secretary, and also to all our respected faculty members and the students. Now, I would like to invite Professor Mohammad Muzammil Sir, Principal of the Zakir Hussain College of Engineering and Technology, to deliver the welcome address. Sir, may I request you to please take the podium?
Thank you very much. Chief guest of the occasion, Padma Shri Professor Ashutosh Sharma, Dean Faculty of Engineering Professor Nisar Ahmed, Organizing Secretary Professor Jamil, Professor Mohammad Danish, Chairman Department of Chemical Engineering, colleagues, friends, and my dear students. It is my privilege to welcome Professor Ashutosh Sharma. Really, we are happy that he is here. He is a visionary person, a scientist, an engineer, researcher, technologist, educator, mentor, and whatever you can attribute with him. He is a source of inspiration for we people. Presently, he is President, Indian National Science Academy, and Institute Chair Professor of Chemical Engineering in IIT Kanpur. He has his excellent academic journey, starting from IIT Kanpur to Penn University, then Sunny Buffalo. After that, he was Secretary to Government of India. Now he is involved with various forums, and he is doing a lot as far as the field is concerned. He is a Bhatnagar awardee. Infosys Prize he has achieved. He has been conferred. TWAS Science Prize, and many other prizes to his credit. He is having a different kind of approach as far as research is concerned, science is concerned. That is, that whatever we are going to do, this should benefit to the public, to the humanity. And with his vast research experience of more than 350 years and a number of patents, all these researches are directed towards that in what way these are going to benefit as far as humanity is concerned. How this can be intersected so that people are going to be having some advantages and more things related to that. Today's lecture is on science and scientists in the new millennium, a brave new world. The topic is very apt. A brave new world is concerned. That is, everything is now changing with a very fast pace. AI has taken everything just by storm. When you are going to think on that, probably scientist community are going to think that what is going to happen in the near future. Whatever we were doing in a month or so, now we can do in a day or two. So the meaning of everything is going to change. How the sustainability is going to be there, how the other processes are going to take place, in what way the future is going to be there. So this is what we are going to have as far as this lecture is concerned. So, probably for this challenging topic, no other person is more relevant than our Professor Ashutosh Sharma ji. So, I once again welcome him, and I hope we all be going to be benefited with this lecture. Thank you very much. Thank you.
Thank you so much, sir, for your warm and encouraging words. Now, I would like to request Professor Nisar Ahmad, sir, to present a token of appreciation to our distinguished professor, Padma Shri Ashutosh Sharma, sir.
To introduce today's distinguished guest, I now call upon Professor Ahmed Tariq Jamil, Organizing Secretary, to formally introduce Padma Shri Professor Ashutosh Sharma to the audience.
Assalamu alaikum and a very good afternoon. With profound pleasure, I express my appreciation and gratitude to Padma Shri Professor Ashutosh Sharma for being with us this morning. He has been my mentor and source of inspiration in my academic pursuit ever since I met him as a doctoral student at the Indian Institute of Technology, Kanpur, way back in 1990. I am honored and privileged to introduce Professor Sharma to this illustrious gathering. Professor Sharma holds Institute Chair Professor at IIT Kanpur, President of the Indian National Science Academy. He is a co-chair of S20 G20. Professor Ashutosh chaired the two-day Science 20 Summit, a significant international gathering of scientific academies from G20 members and invited countries and international organizations in 2023. He served as Secretary of the Department of Science and Technology, Government of India, 2015 to 2021. He served as professor and later as head Department of Chemical Engineering at IIT Kanpur. And he is the founding coordinator of Nanosciences Center and Advanced Imaging Center at the Indian Institute of Technology, Kanpur. Professor Ashutosh received his PhD from the State University of New York at Buffalo in 1988, working with Professor Eli Rukenstein, a recipient of the US Medal of Sciences. His MS from the Pennsylvania State University in 1984 and BTech from IIT Kanpur in 1982. Professor Ashutosh has had a broad international experience as a research faculty at SUNY Buffalo School of Medicine, 1988 to 90, visiting faculty at several universities abroad, such as University of Texas at Austin, University of Western Ontario, University of Erlangen, Nuremberg, and the world-class university program of South Korea. And also, he's a member of the European Research Commission. Professor Ashutosh's research contributions are highly interdisciplinary, spanning a wide range of nanotechnology, thin polymer films, nanocomposites, and devices in energy, health and environment, functional interfaces, micro-nano mechanics of soft matter, nano patterning and nanofabrication, colloid and interfacial engineering, biomaterials, and biosurfaces, wetting and adhesion. He has published over 350 peer-reviewed papers, filed over 15 patents, given over 100 invited or keynote lectures in conferences, mentored a nanotechnology startup. Professor Ashutosh is a recipient of numerous honors and awards, including the Padma Shri in the category of Science and Engineering in 2025 for his contributions in nanoscience and nanotechnology. He has also received 6 Doctor of Science honoris causa from universities in the USA and India. He is the recipient of inaugural Infosys Prize in Engineering and Computer Science. twice Science Prize of the World Academy of Sciences, J.B. Bose Fellowship, Shanti Swarup Bhatnagar Award, Homi J. Bhabha Award of UGC, the Syed Hussain Zahir Medal of INSA, Distinguished Alumni Award of IIT Kanpur and Sunny Buffalo, UNESCO Medal for Contribution to Development of Nanoscience and Nanotechnology, H.K. Firodia Award for Excellence in Science and Technology, Meghnad Saha Medal of Indian National Science Academy. He has several fellowships of several professional bodies. He is an elected fellow of the Indian National Science Academy, the Indian Academy of Sciences, the National Academy of Sciences India, and the Indian National Academy of Engineering, the World Academy of Sciences, and the Asia Pacific Academy of Materials. He has also served on the Council of the Indian National Science Academy and the Indian Academy of Sciences. He has been an associate editor of ACS Applied Materials and Interfaces, Proceedings of the Indian National Science Academy, and American Society of Mechanical Engineers Journal of Micro and Nano Manufacturing, and has been on the editorial boards of several journals such as Carbon, ACS Industrial and Engineering Chemistry Research, Current Science, Nanomaterials and Energy, Chemical Engineering Science, Journal of Colloid Interface Science, Canadian Journal of Chemical Engineering, and Indian Chemical Engineer. Professor Ashutosh's other interests are in ancient history and philosophy, poetry, and art. And that we witnessed when we visited the Maulana Azad Library and Museum. He was so passionate to, visit very minutely and take photographs. Besides these accolades, Professor Ashutosh served as chairman of several academic and professional bodies in India. So just to cut short, I will not spell out all these. So at the end, I understand Professor Ashutosh Sharma will cover the role of science in advancing sustainable development, the role of strengthening international cooperation to help achieve clean energy for a green and just future, universal holistic health, and having better pathways for connecting science to society, culture, and heritage. With this, I invite Professor Sharma to deliver his lecture.
I'm so delighted to be here at AMU. I've been meaning to come here for a long time, and I'm so glad that it worked out now. I have so many friends here. I've had so many students from here. So it's a special pleasure. And the friends here, so it's a special pleasure. And I'm so thankful to Professor Nisar Ahmad Dean, Professor Muhammad Muzami, Principal of Zakir Hussain College of Engineering and Technology, and Professor Mohammad Danish, Chairman of Chemical Engineering Department. Since all my degrees are in chemical engineering, so people think that I'm a chemical engineer. But there are lots of other people who don't know that I'm a chemical engineer. So at different times, they thought that I was a chemist. Then they thought I'm a physicist. Then I thought that people think I'm an experimental physicist or theoretical physicist or material scientist or sometimes biomedical scientist. Because I've been, and then nanotechnology that I've been doing for last 25 years. So what I want to share with you very quickly is that we are not limited by our degrees. And I should, of course, also mention the real person who pulled me here is, of course, Professor Ahmad Tariq Jamil, who was my first PhD student in IIT Kanpur. So this is where my journey, my academic journey started, and I learned so much from him, and indeed from PhD students. But first PhD student is like your first love. You never forget that, you never outgrow that, and I'm indeed very, very thankful for that. So I have had more PhD students who had done BTech from here. There is a Professor Chandra Sharma, who is no relative of mine. Half the world is Sharma around here, other half Verma. right? No, but he was my PhD student from Aligarh, and he has done very well. He's been dean at IIT Hyderabad and many other things. Then I have had Dr. Ashima Shaukat, and I remember her father also very well, who was a professor here. Um, and now she is a professor at BITS Pilani, Goa campus. Very nice. So, what is it I want to talk about? It's not about a particular area of research. What I want to share with you are some thoughts about the structure and processes of doing science. So, each one of us have some areas of interest. We go to our specific, specialized conferences, and we talk about our research. We hear about other people's research. So I don't want to talk about any of that. How many people here have some background or something related to chemistry? Chemistry, there are some, and there are physics and engineering. The rest of them are engineers, are everything. Okay. But chemists. They can solve all problems. You know why? You know why? Because they have all the solutions in their lab. And then I was in a conference in material science. So material science, say material scientists, they do not trust atoms because atoms make up everything. Make up everything. So you don't trust atoms. So anyway, there are, the little jokes about every discipline. Um, what I want to convey, as I said, is look, what are the new challenges of doing science? And new, and a very, very quick introduction to where we are in science, what are the strengths, what are the weaknesses, what are the challenges, what are the opportunities. So here we have what are the overarching challenges of science and technology in the new millennium, and indeed for all the foreseeable future. These are not challenges of organic chemistry, inorganic chemistry, green chemistry, red chemistry, yellow chemistry, none of that. These are challenges which are highly interdisciplinary, and they will remain with us for the rest of the life of planet Earth. So these are rise of intelligent machines. Some part of it we call AI, ML, we call AR, VR, what have you, LLM. So all of those are coalescing together to make this challenge for the humanity, which is the rise of intelligent machines. Sustainable development. Sustainable development is an oxymoron in the sense that sustainability pulls in one direction, and our idea of development, which is only 2 centuries old, pulls in another direction. And it is very hard to join them together. But no matter what kind of scientist I am, this will remain a challenge for all foreseeable future. So I must relate my science to sustainable development and sustainable development goals. Another challenge is balancing between invention and innovation. And I will come to each of these points in a moment. And then inclusion and diversity always remains a challenge because especially in science, engineering, technology, um, sometimes we lack diversity. And I will come to that in a moment and say why diversity is important. So we'll look at the strengths and weaknesses. The third point is what makes science and technology work. So often I used to think when I was younger that in my lab I made something and then I published a paper. I may even apply for a patent, but that's not, it's necessary to do all of that, but it's not sufficient. So what makes science and technology work? And what is the kind of new mind that we need to navigate the challenges of this century, this millennium and beyond? Okay, I may not have time to look into point number 5 as to how the world of science and technology today is not so very different from the world 100 years ago in terms of the challenges of the mind. The challenges of technology keep changing, but the challenges of mind, they are not very different from scientists who were working 100 years ago and the people who are working now. So let's look at the good news. India is number 3 globally in number of papers in science and engineering, and this is up from number 10 just 10 years ago. So we have made very rapid progress. So 10 years ago, we were number 9 or so in number of scientific papers, and now we are number 3. This is also true of including the cutting edge areas in engineering and nano, in materials, in AI, and all that. The number of technology startups have had phenomenal growth. So just 10 years ago, there were 70 technology startups registered in the country. I know this because I joined DST, Department of Science and Technology, in early 2015. So I know exactly 10 years ago what the landscape of publications and patent looked like. There were 70 startups, and today, within 10 years, there are 1.4 lakh startups. So this journey of 10 years from 70 to 1.4 lakhs, it has many messages for us. So this is how we are going from invention to innovation. In fact, I had written an article in Times of India in 2016 predicting that we will have about 1 lakh startups by 2025. And this has come true. The next prediction is another 10 years we would touch 10 lakhs, going from 1 lakh to 10 lakhs. And who is going to do it? It's all the young people sitting here. Sorry, all the younger people sitting here, because I should not forget that I am young and you are younger. Okay, all of us are young, but some are younger. But anyway, so it's the younger people who are driving with the energy, the energy which has been there. Now, there's, of course, India offers hugely diversified markets, lot of demand, and these are the strengths that we can build on. R&D institutions, universities, and demographic dividend that I already pointed out. So this is the strength. The median age of the country is 28.6 years. So imagine what a huge opportunity that is. If we miss this opportunity, it will not come again. This opportunity comes 1 in 7 centuries. Just think about it. So 1 in 5 to 7 centuries, you get demography of this kind. We have a window of opportunity which is now 35 years long. Okay, so after 35 years, 40 years, the society will start graying. It means younger people have to support more people who are not very effective in the workforce, right? So there would be new challenges, new constraints. There would be constraints of climate change. There are constraints of environment. There are constraints of less demographic dividend and all of that, and the rise of intelligent machines and globalization. So these challenges, if we don't deal with them now, in 35 years, it will be not very early. I'm not saying too late, but it would not be the right time to deal with them is now. It's very clear. What are the weaknesses that we have? So while number of papers are large, the quality of those papers is not very high. In whichever way that you judge it, the relevance and direction of research may not be. I'm so sorry, I should have turned this off. The research quality is determined by its relevance and direction. It must connect somewhere. It cannot be a dead end. The difference is between profound and incremental research. So incremental research means that somebody already figured out the basic aspects of that. I'm only filling in some corners. So this is why sometimes we lack leadership and we are happy being followers. So I often hear that these great universities XYZ in the world are doing such and such thing, so it becomes fashionable to do similar thing without understanding actually what the relevance and direction of that research might be. And we don't understand a whole lot of stuff about what is India-centric. And by India-centric, I don't mean only India, but all of actually South countries. And they have certain directions, they have certain needs, they have certain challenges and opportunities. So sometimes we don't understand that, and our connect of the research with industry and society could be rather poor. And finally, the education that we impart does not encourage creativity, independence, risk-taking, and this is starting from school days. So this is the roadmap. Basically, here are the strengths and here are some of the weaknesses, and that in order to get from here to there, We have to focus on these aspects. Now, in fact, I remember, say, how do we focus on weaknesses? I remembered a parable, a story of Mullah Nasruddin. I read that in high school. So Mullah Nasruddin, wise man of the East, so he lost his bunch of keys. So he's searching for them for 3 hours. After some time, his friend also joined him and said he's also searching for 2 more hours. Then he asked Mullah, where did you lose your bunch of keys? He said, I lost them there. So he said, why are you searching there? He said, because there is more light there. So point is, sometimes we do things that are easy, convenient to do, rather than things that need to be done. So there's the same problem with the research in the research that we undertake. Um, okay, so one of the things I want to emphasize about doing effective research, about doing quality research, is not just IQ. It is not just training. It is not how many exams I have cracked. Now, this should be very clearly understood, but often not discussed at all. So we think is something, I have such a great training, I am from this IIT, something. It doesn't matter. Most important aspect of the problems I discussed is the cultural and behavioral aspect. So you hear the questions like why one is a follower rather than a leader, why one is risk averse, why one is not connected to different stakeholders of science and technology, why one is negative and complaining all the time. By the way, this is all I'm telling you from experience. Okay, and I'm sure you have the same experiences, right? So whole lot of time is wasted by having 10 cups of tea every day and complaining. Okay, and people say, if only I had a different head, if I had a different director, if I had different such and such, then I would also get Nobel Prize. Nothing would be more misleading than that. So why do we have low self-esteem? A little translation and innovation, and then people say why there is no Nobel Prize. And the most frequent answer which is given is funding. So if I ask 1,000 scientists, they will say, I don't have funding. If I had 10 crores, if I had 100 crores, then I'll do okay. This logic is very misleading. So while one needs funding, absolutely no denying it, how can we explain that even in theoretical sciences which do not require as much funding, that we are still not leaders? How do we explain that in mathematics we are still not leaders? It does not require 10 crores, right? How do we explain that? How do we explain that even the institutions or the groups that have 100 crores of funding, and that has become the norm now, at least few crores, tens of crores and so on, how do we explain that they are also not counted as leaders in the world? So therefore, we must understand that this is not complete logic. While we need more funding, what we need is cultural and behavioral aspects which start from the confidence, the risk-taking, and so on. I'll come to that in a moment. So what are the future and its technological challenges? Of course, I pointed out the rise of intelligent machines. AI, we may call, quantum technologies are around the corner. There are in biology, great things are happening. CRISPR, for example, gene editing. So these are the technology challenges, but there are also associated socio-cultural challenges. For example, climate change, for example, sustainable development, and so on. These are not problems only of technology. So unless that technology is backed up by societal and cultural and behavioral aspects, will not solve those problems. Preparing the ground for opportunity, what kind of new mind is required and stuff. So let us look very quickly at what makes science and technology work. By work, I mean that there are benefits which are accrued to any aspect of society, any aspect of economy by that science and technology. So of course, there is an invention ecosystem. So invention ecosystem, which includes R&D, which includes discovery science, which includes transmission of knowledge, and so all the education and creating knowledge. So this is an invention ecosystem, and we are very good at it. The country has been very good at it. There are great universities like here that we are sitting. There are R&D labs and all of that. So this is all invention ecosystem. An invention ecosystem is a black box in which money flows in and there's some chemical reaction and knowledge flows out. Okay, so money is converted into knowledge is called invention ecosystem. But there's another thing which is called innovation ecosystem, which is mathematically orthogonal to invention ecosystem, which means that they are a 180-degree out of phase with each other. So what is innovation ecosystem? Most people don't understand this. So if I ask a lot of professors, they will say innovation means a creative idea, which means something very impactful idea and so on. Innovation has nothing to do with creativity. Innovation is another black box in which knowledge comes in and money flows out. Okay, so opposite of invention ecosystem. Convert knowledge into socio-economic opportunity is called innovation. So if you say innovative idea, it means it has potential for socio-economic impact. If it may be anything, it may be a great idea, but it cannot be converted to socio-economic impact, then it is not an innovative idea. It may be a creative idea, it may be a profound idea and so on. So now the stuff is, we understand invention ecosystem, but we have not equally paid attention to innovation ecosystem. And we sometimes say it is not the job of university to do it. Even R&D labs, government R&D labs say, we only do research. We don't care about what this research goes where and how it goes. So this would be wrong, because as I pointed out, that we have to create our students not only good in invention, but also good in innovation. Other stuff is that together with invention, innovation, we need right kind of policies. Without right kind of policy, nothing will get converted into a socio-economic impact. If I had a little bit time, I'll give you a simple example. When we have all the science, we may have all the engineering we want, we have everything, but still it does not work for society because the right policy is not there. Then the cultural and behavioral aspects I already pointed out is most important. And I would, for example, we have heard of this thing about Atmanirbharta or Atmanirbhar Bharat, which means self-sufficiency. Now, you see this self-sufficiency, even in R&D, it depends on three cultural pillars. The cultural pillars are self-confidence, Atmavishwas, self introspection, if you would, the Atma Chintan, and then Atma Samman, which means self-respect. Now, people who have no self-respect cannot respect others. Okay, that should be fairly clear to anybody who has lived 20 years on this earth, right? So we must develop this idea that, you see, we have respect for what people do, we have respect for our neighbors. Instead of pulling them down, we should use our muscle to push them up. Okay, so this is all part of cultural and behavioral aspect. So until we have a control over this, I'm afraid that we would not be leaders, we would not be, be up there and be counted in the world of science and technology. So, okay, the challenge number one, the rise of intelligent machines. This is also called cyber physical systems or Industry 4.0 or IoT. Basically, what is it? The future of science and technology is about convergence. So it is not about fragmentation. Fragmentation has happened over the last 100 years. So we are specialists, more specialists in narrower and narrower areas. But what we require for problem solving is the convergence. So convergence of communication, computing, autonomous decision making, autonomous action, all of this together is called cyber physical systems. Okay, so that convergence is happening very rapidly and it is already here. We live in the age of cyber physical. Now, what would be the next revolution in this? So where would we go from cyber physical? Right, we would introduce biological into this triangle. So we would have cyber, physical, biological. What that means is little bit of digital and physical enters our bodies and little bit of our bodies enter into cyber physical. So that is happening and the future is only all about that. So if you were already, you see, when the first time I did email, this was back in 82 I did first time. I was in the US and it was an experimental system. So that between universities you could do email, and I was thinking to myself at that time, I remember that afternoon so well, very vividly. The first time I saw something like that, and I said to myself, this will solve all my problems of communication. I could not have been more wrong. Today I get 300 mails a day. I don't even have time to look at any of that. So of course, this problem would have to be solved by some intelligent AI agent, okay, that tells me what emails to look at or what not. I mean, all of that will happen. But you see, technology is a good slave, but it's never a good master. We are actually passing through a point of transition where we are not very sure how long we remain master of the technology that we have developed. And so, in order to remain on top of technology, cultural and behavioral aspects are the most important aspects. See, at some point, you would have to ask, what is it that humans bring to the table which a machine cannot? And I'm afraid that answer to that question is becoming more and more difficult, right? I mean, we already know. You can write a poem much better than a high school textbook poem in 2 seconds on any topic using LLM, chat, GPT, anything like that. The other day, in fact, last year, I was going to give a lecture, Foundation Day lecture in Delhi in Patel Chest Institute. Now, I don't know anything about research in chess. I have no idea. But while I was going there in car, I opened ChatGPT and I learned everything about what are the burning problems in chess research. By the time I got there, I told the doctors about all the problems, and they were very surprised. They said, "How do you know?" I told them, ChatGPT, and you guys should also consult it regularly, to update your knowledge about stuff, right? So anyhow, this is a challenge, and it's a challenge because it's impacting every aspect of our life, whether it is learning, work, the future of work, the future of governance, what kind of democracy or other kind of systems will come, whether it's deep fake, how it's going to influence elections, everything, mental health, judiciary, commerce, medicine, privacy, safety, everything, right? So nothing would be untouched. The humans which are here today will not be the humans in 50 years from now. I guarantee you that. Okay, so this is a great challenge. Let's look at the other overarching challenge of science and technology and society, which is sustainability. So we already know what all this stuff is, sustainability, right? Let me just point out that we should realize very quickly that the sustainability is not a problem of science and technology. So no matter what people say, now people will keep telling us that, hey, don't worry about it, technology will solve it. They'll say, oh, the temperature rise end of this century would be 2 degrees Celsius. Make no mistakes about it. The business as usual scenario will lead to temperature rise of 3 degrees Celsius or more. And it would have catastrophic consequences. Now, you see, here is a graph which shows you the carbon emissions as a function of time. While there are more and more green technologies in the last several decades, the emissions have not gone down. Okay, they'll keep on, in fact, the slope of the emissions is also going up with time. So here's empirical data which shows technology is not sufficient. Okay, while we are doing better with technology, we are not doing better with emissions because, what do you think is the reason? Because technology, a more efficient technology only means that per GDP or per consumption, you have less emission, let's say 5% less. But the total consumption overtakes the efficiency of technology. So you have 10% increase in consumption and you may have technology fix which reduces by 5%. So which is a reason that this stuff is always going up, and there is absolutely no way this is going to go down. Even in the COVID time, it was going up. Okay, so it is a collective responsibility, and so therefore, science and technology is not the answer to everything. And I like this quote. Some time back, we say, I used to think the top environmental problems were biodiversity loss, ecosystem collapse, and climate change. I thought with 30 years of good science, we could address those problems. But he was wrong. The top problems are selfishness, greed, and apathy. And to deal with those, we need a spiritual and cultural transformation, and we scientists don't know how to do that. But you see, what he's saying about scientists is true for every section of society. Okay, so this is true. I mean, the point is you cannot change the DNA of humans. Basically, it's a selfish gene. It's a selfish DNA. You cannot change it, no matter who some saint come and go. Okay, nothing will ever change, right? So therefore, what is it that we need to do, right? So it has to be part of the education. So many things are happening in that direction, but it has to gain momentum, right? It has to gain momentum. So you see, our economy, our way of thinking, our way of organizing industry is based on concepts which are only 2 centuries old. Whether it's the Chicago School of Economics, which defines development in terms of consumption, and we have gone further. You see, the civilization which has been there for last 100 years, 150 years, has gone one step further, and they equate happiness with consumption. So the first concept was that economic development equals consumption, and now the second assumption is that happiness equals consumption. Okay, so now unless you are very clear that this assumption is not correct, okay, and I think if you were to empirically examine life, your own life and the lives of others, you can clearly prove that by if I have 5 cars and I add 2 more cars, it's not going to increase my happiness. Similarly, if I had 6 zeros in my bank balance and I added 1 more 0, it's not going to increase my happiness. Okay, and so that should be fairly clear. Now, of course, that we have there's some stuff about what are the priorities of research. I don't have time to go into it, but basically it is about problem solving. It is not about just doing my own little thing. Right? What is my own little thing? Basically, there are 2 different kind of research. One research is called tool-centric research, which means whatever tools I have learned, let's say I am an organic chemist of certain kind, I know certain kind of synthesis and so on, right? So those are the tools. Right now I have this tool and I go everywhere trying to find a problem which will fit that tool. So it's like having a key and then I go from room to room to find a lock that will open with that key. It's very difficult process. Okay, I mean it will not solve problems. The other one is the problem-centric approach, which means I have a problem and I have to develop the tools, I have to collect the tools that would solve that problem. So this is what you would call interdisciplinary, multidisciplinary, whatever you may call it. It requires a different mindset. It's very cultural. So by the way, whenever in my own experience, I have seen and I've seen other people, collaborators we call them, like say to have interdisciplinary, you need collaboration. But people are not very happy with collaborating culturally. They are always thinking, even before collaboration begins, they say, who will be the corresponding author? Then they say, would I be the first author? Would I get the credit? Who will get the credit? Finally, nobody gets any credit because work doesn't get done. I mean, only thing that happens is fight in that process. So therefore, it requires not just science, it requires a different approach to science and doing science. So, okay, I'll not get into that. But let's see, what are the processes of the new mind to deal with these challenges? So we said, look, these are big challenges of the humanity. No matter what kind of science I do, I must connect with these challenges. And in order to connect with these challenges successfully, I knew one needs a different mind. And of course, the cultural aspects are part of that mind. So shift from tool-centric to problem-centric, integration, synthesis, and not only analysis. What I mean by not only analysis, because the education is chapter to chapter. Education is course to course. Education is degree to degree. And so therefore there is no synthesis in any of that. By the time I do one exam, second exam, I have forgotten about the first exam. And so problem is not a problem of a particular chapter or a particular discipline, but it's a problem of synthesis of everything which is known in a meaningful way, and creativity, common sense are important. Understanding and negotiating change will become increasingly important, because there was a time when I learned something in college, and the rest of my life I stuck with one job which only required those tools and nothing else. That's not going to happen now. So therefore, understanding change, negotiating change, in fact, to engineer or doctor change, do not just manage change, but to actively engineer change is going to be the mantra. let's look at what is creativity. So a lot of people say you have to be creative in your research and so on. Creativity is basically connecting those dots of knowledge which have not been connected before, which means being interdisciplinary to create a new subject out of two subjects, if you would, right? So creativity is not something like E equal to MC squared. Of course, there's a different kind. But in today's world, by and large, creativity means connecting those things which have not been connected before, and therefore to discover something new in that process. So here's a story that would illustrate that point. This is the story of atomic force microscopy, or scanning tunneling microscope. Now, basically, when you say you want to see something small, this is the major tool of nanotechnology. Nanotechnology would not have been possible without this tool, right? So the atomic force microscopy, to see something small. So when you think about seeing something small, we always think about radiation, we think about light, right? Seeing means light, right? But there are other ways of seeing. What are other ways of seeing? If I close my eyes, if I could not see through light, then how would I see? Right? Then I would see by taking a stick, walking around, poking the stick everywhere, and then making a mental map of what the stick, the pressure on the stick, right? So the pressure map gets converted into a visual map. So this is another mode of seeing, right? If I convert this idea into a product or a technology, then that becomes atomic force microscopy. So what I work, if I take the stick to be very small, a micro cantilever, and then tap the surface with that stick and convert the pressure map into a visual map, then this is what an atomic force microscope or even a scanning tunneling microscope works on the same principle. So this is another way of seeing, and then you get a Nobel Prize when you just convert this idea of seeing into a technology product. So everything good today starts with a new idea. It does not start with $1 billion worth of equipment. We cannot compete with the rest of the world on saying, I have 100 crores. There are lots of people out there who have 100 crores. You don't get respect because you have 100 crores. You would get respect if you have a new idea, which is no matter how ridiculous the idea might look, but it is possible to convert that idea into something, into technology, into a product or a process. Here's another idea. This is the rise of graphene. So graphene is a two-dimensional layer of carbon atoms, two-dimensional sheet of carbon atoms, which is called graphene. As the magic material is behind a lot of nanotechnology materials, nanomaterials that happen today. How was it discovered? You see, it's discovered very simply. So if you take a block of graphite, so people have been doing research on graphite and its properties. To do that, you need a clean surface of graphite. To get a clean surface of graphite, to remove all the dirt and stuff, you put a tape on the surface and peel the tape and throw away the tape and then look at the block of graphite. That's what people have been doing for many decades. Now this person, what he did is that he did the same thing, take a block of graphite, put a tape, peel the tape, but don't throw away the tape, throw away the graphitic block. Now keep the tape and put it under a microscope, and you see that basically you get graphene by doing sufficient number of experiments. Okay, so it is important that we, in the process of discovery, we do not discard something. Now most of the experiments that we do, they have an end goal or a purpose in mind. So we cannot discover anything in between, okay, because we are totally focused on the end point. And so therefore many interesting things that happen in the experiment, we tend to ignore them, we tend to throw them away, but this is where the real good science is. And so sometimes serendipity works, but only if we let it work. I'll give you an example from my own lab. So because I was working in nano fabrication. What that means is make small things, let's say 10 nanometer thing, an object. How do you do that? There are two ways of doing it. So they are called the top-down method of fabrication, which means using some laser, some radiation, or some machine tool. The bottom-up approach for nanotechnology fabrication is called self-assembly and so on. right? But we thought maybe there's a third way of making small things. The third way may be to make something big and shrink it. Now there's some Hollywood movie I saw in the 80s. It's called Honey, I Shrank the Kids, right? So you say, can't we do the same thing with some object, make a bigger object, easier to make, and then shrink it so it becomes nano dimension. Well, it looks like a ridiculous idea, but I would like to point out that ridiculous ideas can always be converted into technology. That's not a problem. The problem is having sufficiently ridiculous idea, okay, and not throw it away and not start laughing about it, okay. So here is very simple thing. So if you take a three-dimensional complex object and then do the molding of that object with a gel. Now shrink the gel, because by drying the gel, you shrink the thing, then you make the replica again, you continue with this process, do it 4 times, you'll reduce the dimensions by 1 order of magnitude. So this is about shrinking the object. This can be done in a high school. Those of you who work in material science know that one of the top journals of material science is called Advanced Materials, and we could publish this paper in Advanced Materials in 3 weeks of work. Whereas a lot of, sometimes 5 PhDs will work for 2 years to publish in that journal. So point is that I again emphasize that the most important thing is to have a novel, new idea, right? It doesn't matter, whether I'm doing the same thing that other people are doing, that then make too much for inspiration. Now, to give you another example of how inspiration for science may come from different sources. This particular clip, we all of us know. Maybe younger people don't know, but this is a clip from Mughal Azam movie, right? I hope that we can play it. Can somebody help me play this? Of course, the fellow is not looking very happy in the end of it. But what I want to point out here is, you see, there's an inspiration in everything that we see around us. In this particular case, we were fabricating an array of nano lenses, which are shown on your left here. So these nano lenses are created by micro nano fabrication, but by self-assembly. Now we said, look, what is it we can do with this thing, something useful? So what you see is that, like you've seen in the clip, that any object, its miniature copies are made in the array of mirrors. You do the same thing with this array of lenses. So you create miniature copy of anything that you show, and then create an image on a photosensitive material like a paper, right? So this is what is called photolithography. So you can do photolithography by assembling these micro lenses, and this is done by self-assembly. I don't have time to get into it, but okay. So the thing is, often we sit in the lab and we are very focused on our notes and the papers that we read, but inspiration, the new inspiration and new ideas are everywhere. And oftentimes they will just come by good observations, by going around in the field, even going in the movie or anywhere else, and then getting some ideas from there. Okay, this one I wanted to say, look, what are the different ways in which we solve a scientific problem? Not only a scientific problem, but problem of any kind. There are 3 modes of solving a problem that I call Jugaad, Dhanda, and Panga. So Jugaad, we know, is a solution of some kind which is not optimal solution. Okay, but still sometimes we need jugaad in order to live another day, okay, or to make something better. So it's a makeshift solution, not optimal, not scalable, not globally acceptable. The second thing is what you call dhanda, and dhanda is business as usual. So business as usual means is the continuity of our life. Is just saying, okay, 5% increase, 2% increase, whatever, I'm happy with that. But oftentimes we need panga, and panga is the disruptive way of solving a problem. And what I mean by that is, look, if we have done something business as usual for 50 years and we have not solved the problem, to believe that we'll do the same thing another 50 years and solve the problem is called stupidity. So therefore, we need panga. We often do not accept and we do not encourage panga in society at large. But this is required because you have to deal with challenges of the kind which are unprecedented that we have never seen before, whether it is the rise of intelligent machines, or it is the climate change, or it is sustainable development. None of this would be possible by dhanda, okay, because we know that this has not been possible by dhanda. So therefore, 20% at least of societal processes must encourage disruptive solutions. Okay, I just want to introduce to my younger friends what is called knowledge pyramid. So knowledge pyramid is like this. Basically, you start with some resources, the money, whatever, that you do some measurements, you generate some data. From data, you extract information. From information, you extract knowledge. And the hope is that from knowledge, you can extract wisdom. So this whole chain going from bottom to top is called invention ecosystem. Innovation ecosystem is going down this chain. So it's saying start with knowledge, go information, data, measurements, and generate money. Okay, or generate socio-economic changes, okay, of the right kind. So see, this is very interesting. I'll give you a problem. Anybody here works in thermodynamics and IT together? Anybody knows computer science and thermodynamics together? Problem is we don't. We'll never find a person like that other than me, of course, right? So, there's this problem, okay, saying, look, now we start looking at even sustainability of digital cyber world, right? Like all these LLMs, large language models, cartoons, making anything, stories and everything, they have a very large footprint of carbon emissions. People may think, hey, what is this? I mean, nothing, it's all free. There's no such thing as a free lunch. In fact, there is a very good theory in thermodynamics about the interrelationship between entropy. If you want to reduce entropy, then you need to pump in energy. Anything more ordered requires some energy input. You have to do work, right? Now, entropy is also information. So the information content in the entropy, right? So to generate information from data requires energy. Okay, so it is nothing free. Now my question that I want to look at is to get knowledge out of information, what is the amount of energy which is required actually to do that? Anyway, this is a very interesting question. Any of you can actually solve this, will get Nobel Prize. No time at all. Okay, but so therefore probably it's not going to happen very quickly. Let me shift gear and tell you another stuff about doing science, which is, see, if you talk to some person who has white hair, who has certain number of years and so on, who has been in responsible positions, if this person says something is possible, that he may be right. He or she would be right. But if that person says it is impossible, it's likely she is wrong. Why? Because when we say something is possible, it's based on our experience. But when we say something is not possible, we just really have no way to telling whether it is possible or not. And even very, very intelligent people, very experienced people have gone horribly wrong in this world by saying something is not possible. I'll give you some examples. So there used to be this company called Kodak, which had all the market share globally of photography, right? Photography, which are printed photographs, right? But they were also pioneers of digital photography. But their top leadership said that there is no future for digital photography. At the same time, there was another company, IBM, who were the pioneers of personal computer and personal computing. But their top leadership said that there is no future for personal computers and personal computing. Now imagine how horribly wrong they were. And why do you think they were wrong? Not because they didn't have the IQ or the experience or the money at their command and all the tens of thousands of people working at every level. They had a portfolio of patents. They were the pioneers. So the reason that each one of them did not understand the future is because they did not understand the interdependence of technology. See, if you had no applications like digital photography, then you do not need personal computers and personal computing, Windows and stuff like that, right? At the same time, if you did not have personal computers, then you cannot run personal applications like digital photography. So therefore, application and computing and computers go together. So each one of them basically was not looking at what others were doing, what the developments were that were happening at a breakneck speed. By the time they catch up with these developments, already too late. Okay, the world has moved on, and this was happening long time back in the 80s. So imagine the world today is moving exponentially, whereas society's response and the response of the human mind to these new technological challenges is linear with a small slope. Okay, so we say धंधा है, चलता है, होगा, हो जाएगा. So it's like going like this, whereas the technology is going like this exponentially. So if we are not ready for this, there is a energy cost to pay for it. Okay, so this is not related directly, but this is related to the fact as to about how to do good science, how to do good anything for that matter. So this was in the context of when startups do not succeed, but this is of general importance. So I have already talked about the fact that Atmanirbharta requires Atmavishwas, Atmasaman, and Atmachintan. My advice always to younger people, my advice to everybody is the same, but the less young people don't listen to me. The younger people, I can hope to convey something, right? So first thing I say is lose energy vampires. Energy vampires are the people you sit with them for 1 hour, then you will, they'll suck out all the energy out of you because they are so negative about everything. ये तो हो नहीं सकता, वो तो होगा नहीं, क्या कर रहे हो, ये है, वो है, right? They will convince you that this life is not worth living, and the world you are living in is total hell, right? And this is a very major problem. So, and also we have to work with unlike people. This is the meaning of diversity. Why? Because you see, I am a chemical engineer, but I have hardly gone to any chemical engineering conferences. I have to share with you this little secret. I don't mean there's anything wrong with chemical engineering. If I was a physicist of a certain kind, then I will not go to physics conferences because I would have nothing to learn there. See, any new learning actually does not happen when you talk to people who are like you. Okay, so if I already know something or I can learn something, why would I waste my time learning more of it, right? I would rather learn something that I do not know at all. Then I would bring that idea into my own domain of expertise. That is what is called creativity or connecting the domains of knowledge which have not been connected before. So this is very important that we have different perspectives on the same problem. And to get different perspectives, we need diversity, which is why I keep saying, look, we need more women in science and engineering because there's certain perspective on the problem and the solution that we are missing. We need more younger people in decision-making processes because there's some perspective which we are missing. Similarly, that we need to have different kind of people with different backgrounds working together. So this is the diversity in order to solve our problems of the future, that we need to be as diverse as possible, that we need to have respect for diversity and inclusion in everything. Okay, so now I think I have 5 minutes. 2.5 minutes?
5 minutes.
5 minutes, okay, 5 minutes. Okay, so what do we do there? I wanted to give you an example of how policy is very important for science and technology to work. And this is from my personal experience. So when I was in Department of Science and Technology, it is responsible for making geospatial policies for surveying and mapping. For 100 years from the time of British, the policy in India was that nobody can do surveying and mapping without very tedious government approvals. These government approvals are needed from Home Ministry, from Defense, from IB, from Survey of India. Even for the government agencies to get clearances for doing surveying and mapping required 8 months. And so big, ticket items like roads, railroads, tunnels, dams, all of that, or even your personal property, is very hard. We didn't. Has it occurred to any of you that the maps that we use, digital maps, they were not made by Indian company, right? I woke up one time about 8 years ago. I said, why is it we don't have our own maps? The reason is because the policy did not allow it. So even though we may have drone, we may have lidar, we may have science, we may have technology, right? We have a lot of centers we had of geospatial data in universities everywhere. But what can they do? It's criminal to make maps, okay, because the policy did not allow it. So therefore, somebody up there is making our maps and selling it to us, right? So it's our data, and it is our people sitting in Bangalore making these maps, software for it, but the monetization of that happens not by our country, it happens somewhere else. So what is the problem? Problem is a policy, right? So that we had a look at that policy and we reversed it. So we deregulated the sector of what we call now surveying and mapping. No longer any approvals are needed in order to do surveying and mapping by any Indian entity, public or private, at any scale. Okay, so this is a very simple new policy, deregulating the sector, liberalizing it. Now you may think, hey, so what is the impact of this policy, right? What do you think is the impact of this policy in terms of economy? So would you say this is worth 1,000 crores or worth 10,000 crores or worth 1 lakh crores? No, it's worth tens of lakhs of crores. This one line of policy. Why? So some of you may have heard of this scheme called Swamitva. So Swamitva is a scheme in which our rural population who do not have ownership paper for their land are basically, through surveying and mapping, you establish ownership of the boundary, and then you give the ownership papers to people. I mean, most of our rural and semi-urban population actually lack that. And that was the major fountainhead for corruption. All this Tehsildar, Patwari, land is the perpetual source for friction, for conflict, for bloodbath, for litigation. And the fact that you cannot go to a bank and take loan against your land, right? If you don't have ownership, then that land is as good as the gold which is locked up in banks, which is not non-performing asset. So as soon as you do surveying mapping, you give the ownership certificate, then all this economic asset comes out in the market and starts working for us. And so this is what is happening under the scheme called Swamitva. Entire country is being digitally mapped at a scale of 5 centimeters. And so not only for this particular purpose, for every kind of development that happens, that this sector totally opens. Okay, and then there are so many uses for it. I don't have time to go into it. But anyway, let me conclude. Okay, some of the things, it's very hard to conclude everything that we have said. But you say, look, when you look at the future of science and technology, and you say, what would be the developments that would happen? What kind of products will happen? So while we do not know exactly what products and technology will come, but we know the direction of it. So direction is what the mind wants, to be healthy, quality of life, to be connected with equality, to learn, to make decisions in complexity. So for example, when you have AI making decisions for us, this is in direct response to this need of the human mind. Okay, to make, and first of all, I mean, human mind also does not want to make too many decisions. I mean, we're always happy if somebody else makes decision for us. So you say, अरे parents से बोला हमारे लिए ढूंढ लेना कोई match. Okay, I don't want to decide. और बोलना अरे कौन सा job करना है भाई बता दो हमें, कौन सी degree करनी है, कहाँ जाना है. So all of this, you see, human mind is not very comfortable with making complex decisions which have bearing on their life. So therefore, increasingly, we will outsource this activity to AI. Okay, I'll say, please, you make the decision for me. Where should I eat? What I should eat? What my health should look like? How much I should travel? All of that so we're going to be increasingly dependent on technology. to have a better life, to be happy, to find fulfillment, to create and control its own world. This is a basic need of the mind. And the response to that, the technology response to this need is called AR, VR, augmented reality, virtual reality, gaming, immersive experiences, and so on. Now, I mean, we all know that in real world, I cannot control my Begum, but in virtual world, I can. Okay, so I say, you see, and I say, I tell younger people, look, when you are young, you should start a company when you have more energy, right? Because after you are married, you cannot even change a TV channel. Yeah. So this is how it is. But now, see, to live long and maybe forever, this is where the digital twins and the whole concept of cyber avatars will come in. 100 years from now, many different things will happen. I don't have time to talk about it. If you are still interested in knowing how to live forever, I can discuss that. 100 years later, you would be doing that. But anyway, now to conclude, we said, look, happiness equals consumption. Is that true? So this is the concluding slide, and this is totally false, that happiness equals consumption. Okay, and so you see this is called Maslow's motivational model, hierarchical needs. This is something I learned in Psychology 101 back in 1978 in IIT Kanpur. I had not totally understood it then, but now I've understood it totally. So there are these things, these are the needs that we all have. At the bottom of this pyramid are the needs of roti, kapda, and makan. So these are called physiological needs, the needs of security, the need to feel connected, to be social, and so on. So these are called deficiency needs, right? And these are roti, kapda, makan needs, I call them. Okay, so these needs can be satisfied with technology and money and resources. But then once you have some of it, then you get into what is called the growth needs. Now these growth needs are needs the cognitive, aesthetic, self-actualization, transcendence, whatever it is. They are called by different names. Okay, but none of these needs can be addressed, much less satisfied by technology. In fact, sometimes they may be inversely correlated. Okay, so therefore there has to be a balance between what you call the needs of the internal world and the needs of the external world. So roti, kapda, makan is the needs of the external world which can be satisfied with external technology. Whereas there are needs of the mind itself, psychological, socio-psychological needs, which have no direct correlation with technology, and in fact could be counterproductive having too much technology there. Uh, so, um, uh, so okay. Summary. I think we run out of time. So common sense is not common at all anymore. So anyway, this is a very interesting thing to say something. Okay, finally, I would conclude. Really, now I conclude. Finally. Okay, finally, I conclude that to be a good scientist and do good science, one must have a sense of humor. If you are not laughing every day, at least couple of times, then you are going to be depressed. Depressed people never produce anything good. Not only science, but everything else. Okay. So I'll give you an example. So when I joined IIT Kanpur, and I have had, I mean, at the same time, Dr. Tariq Jamil also joined IIT Kanpur. I remember I was very young. Huh? Same year we joined. 1990 we joined. Yeah. So I was very young, and then all everybody there in the department were my old teachers, right? Because I had done BTech there also. So they were all very sympathetic to giving me some gyan, some lessons, and then somebody would come to my office, then somebody is telling me, hey, what you're doing is not chemical engineering. Somebody will tell me I should do something else, right? So one evening I'm a little bit tired, so I tell him, he must be 25 years my senior. I tell him, look, I have done in 2 years what you did in 20. So he said, what? I said, nothing, right? So of course he also laughed. Of course you can do humor only with people who understand it, no, not be offended by it. Okay. So I am very sure, I am very clear about these things. Huh? Unless I discover 2 or 3 new jokes every day, my day is not done. And so all your negativity gets a little bit washed out because of not taking things that seriously about everything. So if you do not take your problems too seriously, you will find a solution for them. Okay, this is the only way to find right kind of solution that would make us happy. Thank you very much for your patience. Yeah, we can have some questions.
Ladies and gentlemen, dear students, I think now you better understand the interrelationship between Yoga, Anna, and Panna of the researcher, right? Okay, so I think we can invite 3-4 questions from the audience, especially our students.
Anybody asking good question, get a chocolate later.
Thank you so much, sir, for your. Myself, Mohammad Uzair Alam, currently third year mechanical engineering student. So I ask a question to you. So, what are the secret to turning my lab research into a startup revolution?
Secret is your passion, your risk-taking ability. See, it's like this. It's better to take risk and fail. There is no shame in failing. I think we have drummed this thing in everybody saying you cannot fail, right? They're totally wrong message. Okay, of course you should not fail in exam, okay? But I'm saying if you have to fail, you have to fail. There is no such thing as failure in life. Okay, you would learn something and then you'll move on. Okay, so most of the startups people they don't succeed in the first go. It does not mean they have failed. Failure is not final. But by the way, success also is not final. Okay, so you must remember that when you are successful, plan for failure. When you are failing, plan for success. Okay, and so it requires, you see, a whole lot of being successful in a startup is a socio-cultural behavioral aspect. It is not about your IQ and your training. See, even a guy walking around in the street with hardly any knowledge, 10% of your knowledge, becomes a successful businessman. Why? Because he has a different traits. He has a different way of thinking about things, right? So the very first thing is your passion and zeal to do it. You would learn quickly because, you have been a successful student. You have come to a great university by tough competition. So obviously you can crack all of this stuff. You just have to be sure about yourself. Yeah. And so actually when people say how to be successful, I say read less, have more passion. All right.
Thank you, sir.
I have not read any book in last 20 years. Yeah.
Next question.
I'm Dr. Azhar Aziz from Nanotechnology. Wonderful lecture, sir, very inspiring. I just want to take one suggestion from you about breaking the silos in the academic environment and to nurture the ecosystem of collaboration and working together across
Right.
disciplines. What would be your one suggestion that we're not yet doing but should do?
Yeah, so you see, there are two things in this. Either one is self-centered or one is centered on the problem solving. If one is self-centered, you can never collaborate. And after a while, the collaboration will fall apart because everybody looking at maximizing their profit, and then it comes in conflict with your partners, right? So thing is my passion coming to satisfy my demands, or my passion is coming for solving the problem, right? So this is a very critical aspect. So we don't, I think Indians in general do not have the stamina and culture for teamwork. And there is a paradox here. I'll tell you what the paradox is. Paradox is that you see in the Western culture, in professional matters, teamwork is very easy, collaboration comes easy. But in the social circle, people are more aloof. You cannot make friends easily, personal friends. So there, it's not so much. But in India, it's other way around. So while personal space, you make friends very easily, in professional space, we don't collaborate, right? So there is a little bit of paradox here. So while as people we are very warm and welcoming, and any stranger comes, they say, "Arey, have tea with me," right? Okay, that will not happen in West, right? But when professional things are demanding it, then you have to do teamwork, right? We are not very comfortable with teamwork. I think this is cultural reason here, is behavioral aspect, and it is also in the final analysis, it has to do with, am I very selfish person, or I have some care about the problem also, that I need to solve this problem, right? So if I care about that problem, I make that problem as part of myself, then I may be selfish in solving the problem, but I'm not selfish in small gains as to who would be the first author, what will happen. People don't want to share anything. People are so secretive. Even things which are in public domain, people say, no, no, I will not share, right? So all of that is very counterproductive for collaboration. And until we collaborate, we will not solve big problems. So people may be happy with solving their small problems about promotion and so on. That's a different thing, right? But what happens? I ask people, once you have become professor, what will you do then? Right? Then there no more promotion. In fact, last promotion I got in life, became professor, was in 97. अब क्या करेंगे उसके बाद? Right? We must solve problems. Our passion must come from somewhere, no, to remain alive. So many things would not will cease to be a motivating factor. So anyway, I don't know. Your question was how to collaborate, right? Collaborate to we should look for right kind of people. I mean, people who are very selfish will not make good collaborators. They may be good in their science. I would stay away from people like that.
I seek to ask two questions.
Yeah.
One is pertaining to whether Jugaad is an outcome of common sense, which denies the very proverb that common sense is least common. Because the skill that is next to labor, they
Yes.
have tremendous common sense,
Yeah.
then the teachers even.
Right.
Second is the happiness is not a measure of material consumerism, and that's what religion has been preaching ever since.
Who has been preaching?
Religion has been preaching
Yeah.
about ever since its inception.
So I don't want to get into religion, the debate about religion. There are aspects, different aspects. So sometimes, religion may discourage creativity or independent thinking. See, it's like this. If I go to Bengal and I write an essay about their hero, they'll kill me. Okay. I mean, because I may not be totally in conformity with what everybody is saying about that hero, right? But if I were to have an independent thinking, right, so then it becomes difficult. So anyway, I don't want to get into complex question of religion, but your first thing that you were talking about is common sense, right? Now, common sense, I said, is not very common because especially in people who are highly educated. It is common in people who are working on grassroots because they have to do jugaad all the time. Their livelihood depends on jugaad. In fact, they are alive from day to day because of jugaad, right? तो वो सब करना होता है, but people as get more specialized, people who become double PhD, they lack common sense. Okay, so that
Please, to
yeah.
be on the lighter side,
Yeah.
religion is not a foreign word here in India.
Huh. I agree with anything you say. I will agree with that. I don't want to get into that at all. Okay, right? Because you see, we all have views about these things, and these views, I can't debate with them, right? They're not a matter of debate at all. Okay, so therefore, and also what we understand by the same word, which are very common, people have different ideas about the same word. Okay, and this is why we cannot converge on a meaning of a particular word and what does it imply in terms of my life and my thinking and so on. But common sense, we must drum in everybody's life, especially people who have become highly advanced in their knowledge sector, because they start losing touch with the real world, right? So a whole lot of problems are problems solved by common sense. They are not solved because I know a lot of equations. I have many examples from my own experience about solving research problems which look very complicated, but I did not solve them simply because I knew a lot of equations. Okay, I solved them for common sense only. Equations come later, okay, to basically publish in a good journal.
So, okay, this we stop due to the time constraint. And I request Professor Danish to present for the science. And that will be followed by Mr. Dharma and Mr. Daniel.
So just want to thank finally everybody who has been so patient here. I think I have overshot my time by a good margin. I usually ask people sitting in front how much time I have left. Then, because sometimes people are polite, they say, take your time, take your time. And last time that happened to me, I spoke for 3 hours. So better not tell me take your time now. I quit here now then, right?
I request Professor Khan to present the presidential remarks. And after this, we follow the protocol.
Thank you, Professor Jamil. I was told that I should at least speak for 2 minutes. So let me try that it should be more than 2 minutes. After having a wonderful talk by Professor Ashutosh, I don't think there's any need to add something more to it. So he has talked about on the topic science and scientists in the new millennium, a brave new world. But let us look at the foundation, which is the first word, science. So I'm going to talk about that maybe 2 minutes or 3 minutes. So what is science? One simple definition of science is it's a systematic approach to understanding the natural and social world, relying on observation, experimentation, and to collect evidences. So this is the foundation of science, that we observe, we experiment, and we collect evidences to support our theories or the law. So if we look around ourselves, the earth and the sky, and the very verse which was recited in the beginning was about our universe, that we should look to, about this universe. So if we look about this universe and we explore it, then you may get several observations and you may collect lots of evidences. One of the story I'm going to tell you, why I'm going to tell you that story, I will relate it to the today's world about the AI actually. One such observation was made by an Italian astronomer in 1801. He observed one celestial object which was named as Ceres, CERES, in 1801, almost 225 years before. And then he observed that particular object for some time, for around 2-3 months, and he took some observation. And then that particular object disappeared. It did not disappear, but it became very close to the sun, so it was not observable. He could not observe it. So he wrote to many scientists at that time, in 1801, that see, I have noted down these observations, and when and where will it appear? So that's a very big question. He was an Italian astronomer. He wrote to many astronomers and mathematicians, and posed this question that tell me that when and where this object is going to appear. So one of the scientists, Gauss, was there, Frederick Gauss, and another mathematician was there. He took this challenge and he wrote to him that this will appear on such and such date. So the Gauss was very much true to that particular object appeared in the sky again after 4 or 5 months and at that location which he predicted. How was it possible? That laid the foundation of the statistics, and whatever we are now doing in AI is primarily based on the data-driven statistics, and we are predicting the things based on those data. So just on the basis of only few data dots, so he was able to predict the things. So what the scientists are doing and what we are doing now in AI actually The primary thing is the statistics, the second is the logic, and we are learning also. So with this remark, I think that I will leave it to you that why observation is very important, and I think that I would like to quote one of the poem which I got from somewhere, and just to provoke you. And I dedicate it to this man, Italian astronomer. उन्हें कामयाबी में सुकून नज़र आया तो वो दौड़ के गए, हमें सुकून में कामयाबी दिखी तो हम ठहर गए. सो जो साइंटिस्ट थे उन्हें कामयाबी में सुकून मिला, लेकिन हम जो है सुकून में कामयाबी देख रहे हैं, इसलिए हम ठहर गए, हम कुछ काम नहीं कर रहे हैं. सो वी ऑल्सो नीड टू ऑब्जर्व अराउंड आवर यूनिवर्स. हमें बहुत कुछ मिलेगा इस यूनिवर्स से. थैंक यू वेरी मच.
Thank you so much, Professor Ashutosh Sharma, sir, for your enlightening talk and for sharing such inspiring perspectives with us today. I am sure your words will resonate deeply with all of us here today. As we move towards the conclusion of this academic gathering, I now request Professor Mohammed Danish, Chairman of the Department of Chemical Engineering, to propose the vote of thanks.
Thank you. A very good afternoon and Assalamu alaikum. It is my proud privilege to extend a heartfelt vote of thanks on behalf of the Department of Chemical Engineering, Aligarh Muslim University, to all those who made today's University Extension Lecture a memorable and inspiring event. First and foremost, I express our deepest gratitude to Padam Shri Professor Ashutosh Sharma Sahab, who is Institute Chair Professor at IIT Kanpur and President of the Indian National Science Academy, INSA, and he has also been served as Secretary DST of Government of India. Sir, your lecture on science and scientists in the new millennium, a brave new world, was not only enlightening but also thought-provoking. It has left us with many new ideas and perspectives, especially for our students and young researchers. And from my own personal view, sir, may I ask a question, personal question? Being a chemical engineer, we have seen a new dimension of a chemical engineer, and that you have shown through lecture. तो आपको बहुत सारे अवार्ड्स और सर्टिफिकेट्स मिलते होंगे. ये आपने मतलब इसके लिए कमरा डिवोट कर रखा है या उसके लिए पूरे फ्लैट? Anyway, it was a wonderful talk.
असल में उतना मेरे पास कमरा वगैरह नहीं है और वो सब अलमारी में बंद पड़े नहीं. पता भी नहीं कहाँ क्या पड़ा. उसका कोई उपयोग, मैं ये कहना चाहूँगा, ये सब अवार्ड है ना, उनका कोई उपयोग नहीं होता. और अगर उसके साथ बहुत ज़्यादा पैसा नहीं हो अवार्ड के, तो मतलब ही नहीं कागज वागज है.
यस ऑफ कोर्स सर. मगर ये केमिकल इंजीनियर को इतनी डायमेंशंस में देखते हुए बहुत अच्छा लगा, और मेरे ख्याल से जो यंग स्टूडेंट्स हैं केमिकल इंजीनियरिंग के या अलाइड ब्रांचेस के पेट्रोकेमिकल इंजीनियरिंग के, उनको भी काफ़ी इंस्पिरेशन मिली होगी सर को देख के. Now coming to the vote of thanks again, we are also honored by the presence of Professor Nisar Ahmed Sahab, who is the Dean Faculty of Engineering and Technology, who presided over this event with grace and shared insightful remarks through his presidential remarks. I am also thankful to our principal, Professor Mohammad Muzammil Sahab, for his welcome address and his continued support behind the scenes. A special thanks goes to Professor Ahmed Tariq Jamil Sahab, who is the organizing secretary for this university lecture, and for introducing the distinguished speaker and for his tireless efforts. I must also acknowledge Professor Nisar A. Khan Sahab, who is the coordinator of University Extension Lecture, for his invaluable contribution in planning and execution. My sincere appreciation to all the faculty members especially Naseem Sahab, Dr. Parvez and Dr. Wasiur Rahman, besides the staff members, students and our esteemed guests whose presence enriched today's gathering. Last but not the least, I extend my gratitude to all the supporting staff and technical teams who worked silently to ensure the smooth conduct of this event. Thank you all once again, and let us carry forward the ideas and inspiration we have gained today through this University Extension lecture. Thank you.
Thank you, sir, for expressing our collective gratitude so eloquently. With this, we come to the end of today's enlightening and inspiring program. On behalf of the Department of Chemical Engineering, I extend my heartfelt thanks to our esteemed speaker, respected faculty members, and students for being a part of this academic celebration. I now request you all to be please present for the AMU Tarana, which will be followed by the national anthem.
Ah अधिनायक जय हे भारत भाग्य विधाता। पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा। विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा। तव शुभ नामे जागे तव शुभ आशीष मांगे। गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता। जय हे जय हे जय हे।